Cool. I want to welcome everybody out tonight to Austin on Rails. Thanks for braving the weather to get here. Tonight we're going to be doing two talks. One on creating a Rails gem, given by Claire Glinka, and the other talk about using Rails engines to break up your application, and I'm going to be giving that one. My name is Jeff Felchner, and I've been doing Rails since about 2006. I have quite a bit of experience creating some fairly large applications for some of our clients at our consulting firm. And so anyway, I want to thank the Capital Factory for letting us come out here and do this thing tonight. We're going to be live streaming this tonight. I think this is the first Austin on Rails that we're going to be doing that with, so that's pretty cool. Let's see. Does anybody have any announcements that they want to make before we get everything kicked off? Anybody?
Oh, got one.
Okay.
My firm is actually looking for some senior Rails developers for one of our clients, so if anyone's interested, you can talk about this.
Okay, cool.
We've got a little section. We do a little section in the middle where we actually let you talk about that stuff and then actually meet people right in the middle section.
Yeah, so if you're looking for people or you're looking for a job, we'll be doing that a little bit later. So. Just so that everybody knows, bathrooms are back that way. You go towards the desk, take a right, and then you'll see signs. The men's restroom is to the left, and the women's restroom is to the right. Sorry, this is my first time doing the emceeing thing, so I'm a little bit unsure of the whole work, the whole flow. Let's see. So a little bit about how things are going to go tonight. So first we're going to do, we're doing the announcements, and then we're going to go into the first talk, which, like I said, is going to be Claire. Then we're going to have a little bit of a break. We'll do the part where we do if anybody's looking for jobs, we'll do that. We'll do a raffle, and just have a little bit of a break for bathrooms and stuff. And then we'll come back. We'll do the second talk, and then we'll close everything out and head on to BD Riley's after the meeting's over. If we have a food sponsor tonight, if they would like to come up and say a little bit of something real quick. Absolutely.
Hi, I'm Jenny, and this is Kimmy. And we are technical recruiters at Tech Systems. We're a technical staffing agency, and we're sponsoring the food tonight, so come talk to us in the middle. We're going to leave some of our cards on the table as well. If you guys don't get a chance to talk to us, feel free to reach out. We've been seeing a lot of Ruby on Rails positions recently, and I've been placing a lot of people within this space specifically, so pretty knowledgeable about it. So come talk to us. Thanks.
All right, and with that, we're going to start off with the first talk, and Claire's going to come up here and do that. So give her a big round of applause.
Just a sec, I was set up and not anymore. There we go. Thanks. As you said, my name is Claire, and I'm going to be giving a brief presentation on how to make a Ruby gem. First, I just wanted to briefly talk about who this talk is aimed at. Basically me a couple months ago when I was making my first Ruby gem. So this is for people who are new to Rails, possibly new to Ruby, and possibly even new to programming. So I will be talking at a fairly basic level today. So to start off, there's a couple different tools that will help you to make gems, including Bundler, Jeweler, Gem Cutter, and many others. And today I'm going to be talking about Bundler for the most part. Gem structure is actually very simple, and so technically you could write all of the files by hand very easily. But Bundler is a little bit like Rails. in that it just generates sort of an empty skeleton for you and sort of sets you up to use some of the best practices when you're building your gem. So I'm going to run through building a gem that generates choosing adventure plots with Bundler. And so the not really first step, just in case, probably most people already have Bundler installed, but if you don't, then install Bundler. And so to generate that sort of skeleton or outline, you're going to say bundle gem and then the name of your gem. And so in this case, it's going to be adventure. And so you'll see an output that looks a little something like this. You're going to have a bunch of different files created, and it's also going to initialize a Git repository in that folder for you, which will be important later. Sorry about that. So your structure or your folder is going to look a little something like this. You're going to have a main folder that is the name of your gem. It's going to have a bunch of files in it, and then a lib folder where sort of the actual functionality of your gem is going to live. So now that we have our sort of skeleton, the thing we want to do is finish our gem spec file. So the gem spec is just in the main folder, and it again shares the name of your gem. So in this case, it's going to be adventure.gemspec. And the gem spec is the file that tells the gem how to be a gem. So it's sort of all the metadata, all the files, all of that is defined in the gem spec. And so this is separate from, say, the functionality of what function your gem actually performs. And so the gem spec file looks a little something like this. We have some information about the load path, and then gem specifications that are set. And so to start out, I'm just going to walk through the gem spec and sort of explain what each of those pieces do and why they are or are not important. So to start off with, there's a couple specifications that are required. It won't let you build the gem unless you have these defined. And then Bundler actually gives you some additional optional gem specifications that I'll go through in a minute. So to start out with, your gem has to have a name. If it doesn't have a name, who knows? It's all complete insanity, apparently. And Bundler will actually set this for you when you do your initial command giving it its name. It automatically sets the name. The key thing about picking a name for your gem is that names are forever in the gem world, especially if you're going to release it publicly. So pick your name carefully, and if you're going to release to a public repository like Ruby Gems, you probably want to check and make sure the really clever name you've picked hasn't already been taken, because there can only be one gem by any given name. The next really important piece is the version number for your gem. You have to have a version. And there's actually two pieces to this in your gem specification. First, you have your spec.version, and you can see that that's actually set to a constant inside a module. And then the place where it's actually going to find that information is in the require statement at the top. It's requiring a file called version inside a folder called adventure. And so if we look at our little tree, it's down there at the very bottom, it's version.rb. And this Bundler makes this file for you, and even gets you started on your very first version. So for now, you don't have to actually do anything there, but you do need to know where that is. And so a brief digression about versioning. It is the best practice to use what's called semantic versioning. I'm sure many of you are familiar with this, but just in case, semantic versioning is all about telling your users information about compatibility in your version number. So the very last place in your version number is for fixes. The middle number is for additional functionality that does not break backward compatibility. So if I update my gem, nothing will break in how I'm already using the gem. And then the very first number is for additions that do break backward compatibility. So if you're going to break somebody's use of your gem, you want to increment that portion. And this is important because a lot of people define version constraints with what I call the squiggly arrow, or I guess it's technically called the twiddlewaka. And if they're defining versions like that, you don't want to break people's definition. So if they define, for instance, 1.2, that means all instances before version 2, so any updates, any additional functionality that will not break the way they're currently using your gem. Or they could be even more specific and say, I don't want any additional functionality, I just want bug fixes, and define their version out to the very third place. So in summary, be kind to your users and use semantic versioning. So you are actually required to have a summary in your gem. So that's not very complicated. And Bundler even puts a nice little to-do statement there and lets you know that the summary is in fact required. They also provide a description field, which is not required, it's entirely optional. So I'm going to go ahead and give adventure plot generator as the summary for my gem, and I'm just going to leave the description blank. And if I wanted, I could delete it entirely. The next important piece, and this is important in how your gem is actually going to function, is the require paths. So you can see down there at the bottom, require path is set equal to lib. This is important because anytime you use a require statement inside your gem, that's where Ruby is going to start looking for that required file. And then as you can see at the top, we are setting lib equal to all of the files in the lib directory, and we're actually adding that to our load path. And so this was something that was a little confusing to me when I was getting started. I didn't really understand what the load path was or how exactly it was supposed to be working. So we want to protect the load path, and so just quickly, we can actually look at the contents of the load path in Pry or IRD. And so you just say load path, and then right now I'm highlighting the gems that are currently in my load path, right? So they're all in a folder called gems, and then each gem is inside its own folder that is the name of the gem with its version number. And then you can see that each of those gems has its own lib folder. So basically the contents of each gem's lib folder is sort of swimming around in the namespace with the lib folder in every other gem. So you want to keep the contents of your lib folder very neat and tidy so it does not interfere with anybody else's gem. So say I'm requiring my adventure gem, and I look at my load path again, I can see that the lib directory of my gem has been added to that sort of swimming pool. So technically, if I wanted, I could have a file called, say, active record, and if I required active record, and it found my active record before the real one, it would actually use that. So you want to keep your lib folder tidy. Don't include things in your lib folder that are not named for your gem. And so the folder I'm talking about is the adventure folder inside lib. And so anything else that you would need to add to your gem will live inside that folder. The next really big piece of your gem is going to be the files specification. And this is where any kind of functionality in your gem is going to live. So you want to have that. Bundler automatically gives you a way to manage the files with Git. And so that's why that initialize Git repository was really important at the beginning. And so just to sort of go through exactly what this command is doing, if you do git ls in your terminal, you just can see all the files that Git is tracking. So what does this actually do in Ruby? So if we do the git ls files command that we see in our gem specification, we actually see it returns a string that contains that same list of files. And then if we run the whole command, it basically returns an array of those file names. So if you wanted, you could actually replace that git ls command with just an array that lists all of your files. And so that would be fine. That would work exactly the same way. You would just need to, by hand, add any files if you added additional files to your gem. And these both mean exactly the same thing. And there's actually even another way you can do it with the dir glob command. And so again, looking at it in Pry, you get that same array of files. The only thing you have to be careful about if you use this version is that if you have any extra files that don't actually belong in your gem, they will be included because it includes everything. So if you're like me and maybe put little pieces of extra things in a file for later sometimes, that might not be as big a choice. And the last required specification is Ruby Gems version. And this one was pretty confusing because when I was reading about all of the required ones, I was like, okay, so what do I do with this? And it turns out that's automatically set up for you when you build your gem. So you actually won't see it anywhere in your gem specification file. It's just magic. So those are all of the things that are required. So as long as you have those things, you can build a gem. But Bundler gives you some other information that you might want to include, like who wrote the gem, and what your homepage is, and what kind of license it's released under. So I'm going to run through a couple of these really quick. And then we'll finally get to the writing the actual gem part. So these next couple are pretty self-explanatory. By default, I have my git config set with my name and email. So when I start a new gem, it already knows about me and fills in my name and email address. And for a homepage, I'm just going to point it at my GitHub. If I had a website for whatever project I was working on, I could point it at that. Or again, since this is an optional one, I could delete it entirely. The next, probably a little bit important piece is the license. By default, Bundler sets the license to the MIT license. You can release it under any kind of license you want and change that field. If you do that, you should probably go in and change the contents of license.txt because currently it contains the MIT license. And then the last two that I'm going to talk about right now are the executables and test files. As you can remember, when I was talking about the spec files, it's just handled by Git right now. And so these two are actually just subsetting that file list. For the executables, it's looking for the files in the bin folder. And for the test files, it's looking for any files in a test folder. And so again, you could handle this manually if you wanted. They're also not required, so you don't need to include them if you don't want. And so now we are ready to write some code. We're going to start out in the adventure.rb file in the lib folder. And Bundler has very helpfully gotten us started. We're requiring our version file, and we have a module called adventure, and they're even pointing out that our code goes there. It is important that everything goes inside that module. If you try and put code outside of the module, or you have another file with code in it, and the code is not wrapped inside that module, you'll get really weird and confusing errors. So keep your code inside the module. So for my adventure plot generator, My desired output is I just want this gem to print a string, right? And I want it to be, there's a character with some funny quality and another character with something else that is kind of entertaining, and they fight crime because I'm easily entertained. So, I go through and put together some code. I have a plot class and a make plot method. And I'm defining some characters and having it return a string. So now I've gone through and I think this should work out. And so the next step is to build and install a gem. And there's actually an easy way and a really, really easy way to do this. So I'm going to do the easy way first and then the really, really easy way. And so the easy way has 2 steps. First, you have to build the gem with the gem build command, and you just give it the gem spec, and it looks inside the gem spec and is like, okay, here's all the information I need, and puts together your gem. As you can see here, it's giving me a warning that I have not filled out my description, but since description is not a required characteristic, it'll go ahead, or required specification, it will go ahead and build the gem for me anyway. And so, it's successfully built, and it has a name and a version, and there's even a file. And so if we go and look, this command by default just puts your gem file in your main folder, just hanging out there with all your other files. And so now that we have a gem file we want to install, and so like most gems, we just gem install, but here we want to specify the version number so it finds it there in our folder. And if everything has gone well, it will tell us that we've successfully installed it. And so now we can go into pry or IRB and require it and make a new plot object and call make plot on it, and hooray, it works. We have a cheesy adventure plot. They fight crime. And so now we're going to talk about the really, really easy way. Bundler provides some break tasks for you that make this ridiculously easy. And so you can see down here at the bottom, we have 2 development dependencies, bundler and break. And one thing that's a little bit different about gems is instead of handling all of your dependencies in your gem file, you actually do that just in your specification file. And I have seen that there's some contention about whether you should do it in your gem file or your gem spec file, but the current consensus seems to be put your dependencies in your gem specification file. So let's take a quick look at what our gem file and break file would then look like. So the gem file is built for you by Bundler. It's just specifying a source and telling you to specify your dependencies in the gem spec and then just pointing at the gem spec. And the reg file is equally empty. It's just pointing at the gem tasks that Bundler has set up for us. And so if you want more reg tasks, as I mentioned earlier, there are a lot of different tools for building and managing gems. And many of them come with a giant list of reg tasks that will do various things for your gem. So the ones that Bundler gives us are rake build, rake install, and rake release. And so I'm just going to run through those really quickly. So rake build does exactly what you would think it would do. It builds your gem. The only difference here is that it doesn't put the built gem just in your main folder. It makes a new folder called package and stores the gem in there. And if you would just like to do the whole thing in one single command, you can say rake install, and that will actually build the gem for you first, and then install it, and then you're really ready to go. And again, there's our gem folder structure, and our gem is in the package folder now. So now we built our gem, and we've tested it in Pi, and it works. and it's all really, really exciting. So we are ready to release our gem. And so the first thing you just need to do is make sure you have an account with rubygems.org or the gem host of your choice. And you get to do the really simple command rake release, and that will build the gem and push it out to Ruby Gems. And again, like I said, you have to have a unique name. So if your name is already taken at that repository, it won't work. And since this is the first time you've done this, maybe, and everything has gone terribly wrong, there is a kind of way to fix it with the gem yank command. And basically what that does is it just tells rubygems.org that there's something wrong. We don't want anybody else to be able to download this version of the gem. So use it with caution. Understand what you're doing when you do it. Otherwise you'll be really confused. And when you go back and fix your gem, you'll actually need to make sure you increment your version number because you can't re-upload the same version. Okay? So be careful, but it's a way to kind of fix everything if something has become a disaster. But mostly just check your gem before you push it up. So now that the first version of our gem is wildly popular, because who doesn't love cheesy adventure plots, I'd like to improve it, right? And so I'm not any great literary mastermind. I bet people have way better ideas than the things I hard-coded into the gem. So I would like people to be able to create their own JSON object and sort of edit that with whatever really awesome plot devices they can come up with. So to do that, we're going to have to add the JSON gem to our gem. And we're going to do that with the add dependency specification. So this is basically going to work exactly like our development dependencies, right? Except instead of a development dependency, it's just going to be a dependency. And so we add it to our gem specification exactly the same way. Bundle install. And then we can go and refactor our code. So it looks something like this. And so we can go and refactor. And we're just going to require JSON at the top of our file like we would normally and use it in our code. And then we can use our rake install command. But there's just one problem. We've already released a version of the gem that's 0.0.1. And so we can't push this updated version to Ruby Gems yet. We need to update the version number. And we've also broken backward compatibility, right? So anybody who's already using the really great first version of our gem, it will break if they update. So we need to just go into our version.rb and update the version number. And this time we're actually going to increment that very first number because that's for major changes that break backward compatibility. So now we can rake install again and double check that everything works the way we expect it to work. So clever dragons fight crime, everything looks about right. And so now we can again push it back up to Ruby Gems. So the very last thing that I kind of want to run through really quick is how to set up testing in your gem. People really like it when you test your gem because they're trying to use your functionality in theirs and they want some kind of assurance that your code isn't going to ruin everything. Or at least works the way you say it's going to work. So I'm just going to run through setting up testing with RSpec. So again, we're going to add another development dependency, and this time it's just going to be RSpec. There at the very bottom of our file. And then if we want, we can initialize RSpec, and that will make us the helper file and the config file. And so it's just going to add that to our main folder, like so. And so this is the spec helper file that is automatically generated. I'm sure you've seen it all before many times. And so we're just going to require our gem in the helper file, which should allow us, when we make our spec adventure file, to just require the helper, and then as per usual, we'll write our tests. We're going to describe some stuff, and it's going to do something. And so then we can bundle exec rspec, and our test should run. But if we want to set up the rake files, we can do that too. So we're just going to go into our rake file and add and require the rake tasks from rspec, and make a new rake task. And then we can rake spec and run our tests that way, because typing extra letters is dumb. So there you have it. You have your very first Ruby gem that does really cool stuff. One of the best resources I've found for information about making Ruby gems is the rubygems.org guide. And if you found this presentation really awesome and exciting and really didn't have paper to take notes, I'll actually tweet a link to the slides when I put them on the internet at my Twitter handle. So thank you for listening, and if anybody has any questions, I will do my best to answer. Then I guess it's break time.
All right, so what we're going to do now is the bit where we're going to ask if anybody is looking for a position right now. Go ahead and put your hands up. Put your hands up. 1, 2, 3, looks like. Okay, and how many people are looking to hire? 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right. So those of you who had your hands up, here in a second, you can all come up and meet right around this area, and we will. You guys can mingle and discuss and do important things. We are also giving away 3 books tonight. I'm going to have a raffle set up here. Just come up to my laptop and put your name in, and then we'll run that raffle a little bit later before the next talk. Let's see here. I think that's it. So if everybody wants to just take a break for a second, we'll be back here around looks like around 8:15. Right? Thanks.
Yeah.
All right, everybody. I think we're going to get the second one started. Hello, everyone. Welcome to the second presentation. So, as I said before, my name is Jeff Felchner, and tonight we're going to be talking about using Rails engines as a way to get your app to a service-oriented architecture without having to take a ton of time to spend like 6 months of pulling out this huge app into different pieces. We're going to do that with a few different ways. It's my obligatory keynote effect. All right, so before we get started, I just want to let everybody know that we're, like I said before, we're going to be Capital Factory's live streaming this thing tonight. So if you guys don't feel like taking notes, I think it's going to be available after the talk. Second is that I'm going to be going over this stuff at a very, very high level. There's a lot to it. If any of you are interested in more information, I would be happy to talk to everybody either after the presentation or we'll be out at BD Riley's a little bit later as well. The third thing is that I don't always talk in absolutes, but when I do, I usually never mean it. So if I say always do this, don't always do this, I don't mean it literally. It's just the way that I am. That's what my personality is. So. The most important thing, though, is that at some point during this talk, there's going to be a an obscure 80s reference at some point. If you get that obscure 80s reference, I'm going to give you a $20 bill. And you can actually give that $20 bill back to me, and I will give you a couple of hours of pairing time, at which point we can work on whatever you would like. That is substantially lower than my typical consulting rate. At every point during that pairing session, you will be looking at me like this, and at absolutely no point during that pairing session will I be looking at you like this. All right, so let's get started. So whenever you all are working with your Rails app, how many of you have been at a Rails app where your test suite takes, like 5 minutes to run? About 10 minutes or 15 minutes? 30 minutes? Anybody? Longer? Yeah. Some of the legacy applications that we get can take, with the acceptance test and everything, can take an hour and a half to run, which is just completely ridiculous. So obviously, whenever you have a Rails app that has these kind of test suites, it's very, very difficult to add new tests, which means that you don't want to add new tests, which means that you begin to fear change, because when your test suite doesn't reflect what your application does, you have no confidence that, the changes that you make aren't breaking things. How many of you have a Rails app that is so large? When you first started, you could do it, but now it's so large that you can't fit it all in your head all at one time. This happens all the time. New features get added, new concepts get added, it's just ridiculous. So whenever you first start with your Rails app and you do Rails new, it feels like you're going on a cross-country road trip with your best friend, knocking over liquor stores and like firing guns in the desert, and it's just awesome. But eventually you realize that some of those decisions that you made early on have repercussions that you weren't anticipating. And your Rails app still feels like your best friend, but you're starting to get scared that your best friend is changing and you don't know what's going to happen. And then eventually you're in a cabin in the middle of the woods and your Rails app is possessed and it's trying to kill you. So what we're going to work on tonight is taking your Rails app and trying to tame it a little bit. So how do we fix this? Well, we're going to do it with a little bit of object orientation. So your Rails app starts out, and you have this big box. And everything that you do with your Rails app fits inside that box. Well, what we're going to do tonight is we're going to shrink that box down a little bit. We're going to split it up into a few different pieces. But we're also going to create well-defined interfaces between each of those pieces that you can use to talk to them, so that you're not coupling every bit of your app to every other bit of your app, which is typically what happens inside of a monorail. And the way that we're going to be doing this is with a mixture of 3 different things. So the first is standalone Ruby gems, like what Claire talked about earlier. And is going to be functionality that has little to do with Rails and mainly can just stand on its own. The other thing that we're going to be talking about, not quite as much, but a little bit, is rail ties. And lastly, we're going to be talking about Rails engines for the bulk of the talk. The important thing to note about Rails engines is that they are actually Rails gems. Or I'm sorry, they are actually Ruby gems. So you would use a Rails engine exactly the same way that you would use a Ruby gem. It gets pushed up to rubygems.org, or is on a Git repo that you would pull down using bundle install. You would bundle update it like this, just like any normal gem. And when I'm developing, I typically put it in my gem file like this, especially when you're first starting out, pulling your engine out. You don't want to have to like push up to GitHub and then pull down on your main app every single time. So I usually do this until I'm more confident that it's something that the other developers on the team are ready to look at. So let's first go through the 3 different pieces and talk a little bit about them if you're not familiar with them. And then we'll go into an actual example that we had that is kind of taken from some of the client work that we've done in the past. So the first one is gems. And like I said, gems are anything that you think might potentially make a good open source project. Now, this doesn't mean that you have to release it publicly, but if you think that it could be released publicly, then this is a good opportunity to use a gem. But you're probably asking, like, if I don't want to release it publicly, how am I going to work with this gym, with the team that I'm on? What are the ways that we can go about doing that? Well, there are 4 different ways. The least useful way is to modify your gym path. So you can locally export your gym path to include the path that your gym lives at. And when you do a require, it will pull that gym in based on where it's looking inside of the gym path. That's not very useful. More useful is to use a private Git repo inside of your gem file. So most of you know that Bundler will let you do that inside of your, that should be a Git repo, but you know what I'm talking about. That should be, you can do that inside of your gem file, and then you can do a bundle install, and it'll pull from GitHub or wherever you have your Git repo set. You can also run a local gem server. So a lot of people don't know that you can do this. If you run gem server like that, it'll start up the server on your local host that'll be available at port 8808. And if you go there, you'll see the list of all the gems that you have installed. And you can actually add the source to your local gem command. And whenever you do a gem gem install, whatever, it will look in rubygems.org, but it will also look on your local machine. So you can basically run your own local RubyGem server on your own. If you add it to your gem file like this, then it will look there for your gems whenever you run Bundler. Lastly, and probably the most useful, is if you want to use a third-party service like Gem Fury, you can create an account there, push up your gems to Gem Fury, and then inside of your gem file, you would reference the URL that Gem Fury gives you, and when you bundle install or you gem install, it'll pull from there as well as from RubyGems. All right, next up is rail ties. So rail ties are interesting. They're not as useful as a standalone solution, but they are a tool that you can put in your toolbox. So they are not a type of gem. They are a class that you include in a gem that you've already created. And it extends from Rails rail tie, and it gives you some hooks into Rails. So you would add a line maybe to your gem that looks like this, where you're requiring your rail tie, but only if you're loaded inside of Rails. And then that way, if you run your gem outside of Rails, you still have all of that functionality, the non-Rails specific functionality, but when you are inside of Rails, you can get some added goodness. Now, an example of some of the things that you can do, you can add middleware to Rails, you can create and update configuration settings, you can add generators, you can run code at Rails console load time, you can add rake tasks, and you can create Rails initializers. The rail ties give you the ability to also run code at various points during the Rails load process. At any of these hooks that Rails defines, so these happen from earliest to latest, and if you run code during there, you'll have access to obviously various bits of Rails that are currently loaded versus if you go later, you'll have access to more information once Rails has run more stuff. So let's look at a concrete example. Most of you have installed RSpec Rails before. When you install RSpec Rails, you get access to the rakespec command. But at no point after you install RSpec Rails do you ever have to like copy a rake file or move anything from the gem. And the reason why this works inside of Rails is because RSpec Rails has a rail tie. So let's take a look at that real quick. So this is the literal code of RSpec's rail tie. And you see there at the bottom, when you subclass from Rails rail tie, you get access to a DSL method called rake tasks. And anything that you do inside of there will get loaded inside of the rake tasks that are available to your Rails application. So there we're adding the rspec.rake, and that's how we get access to that. You'll also notice that we have a couple of config options that have been set in there. This is what causes Rails to create specs for you instead of tests whenever you do Rails generate model, whatever. That's all done through the RSpec rail tie. All right, next we're going to talk about engines. One of the interesting things about an engine is that it actually is a rail tie. So all of the functionality that you have inside of a rail tie, you can also get inside of an engine. But even more interestingly is that your application is an ancestor, or your engine is an ancestor of the Rails application. Actually, the Rails engine does the bulk of the work. Rails application doesn't put very much logic or functionality on top of the Rails engine. So by using a Rails engine, you basically have everything that you can do inside of a Rails app, you can do inside of a Rails engine. Now, you might be asking, well, what kinds of things? Well, most of you who do authentication probably use this guy right here. Devise is a Rails engine. That's why you get access to mailers and views and all kinds of things, because Devise puts that inside of the gem. You may use ActiveAdmin, is also a Rails engine, gives you access to all kinds of views and controllers and routes. You may not use this one, but it's also very handy. Spree will create an entire e-commerce platform for you inside of your Rails app with like 3 lines of code. And so you can do things like add images, CSS, JavaScript, models, controllers, observers, mailers, migrations. All of that can be done inside of your Rails engine. The migrations are kind of cool because if you run your migrations, if you run a task inside of your main app, it'll actually copy the migrations from your engine into your main app and then run them, and they're all namespace, so you don't have to worry about name collisions or anything like that. If you have routes inside of your Rails engine, you can mount them to your main app at a specific path if you choose. So if I had a route inside of my engine called foo, and I mounted it like this from my main application, I would be able to go to /myengine/foo, and it would run through the controller inside of my engine, rather than through my main Rails application. This is the reason why inside of ActiveAdmin, you can go to whatever my app is, /admin, and get access to all of that functionality, because it's being mounted to the /admin URL. All right, so we went through all the different options. Let's talk about what we're going to do now. And for the sake of this presentation, I'm going to assume that everyone has a full test suite. This is really important because the changes that we're going to be making here are very, very large, and you want to make sure that the changes that you make to your app aren't going to be breaking things that you didn't anticipate. Now, if you don't have a full test suite, I would at least recommend that you have acceptance tests that go through the main parts of your application before you attempt any of this stuff. So that's my disclaimer. Whether or not you'll decide to heed that advice is up to you. All right, so let's talk about gems. We'll go back to gems. What we're going to do is take our main application and find some functionality and pull it out into a gem. For this example, we're going to be talking about addresses, because we all deal with addresses every day inside of our applications, or most days. I was very surprised to not find a very good address gem that dealt with all the different things that you have to do with addresses on a regular basis. So we're going to create one. And some of the things you might be doing with addresses are formatting them. You might be converting them to and from latitude and longitude. You might be validating them. You might be verifying them against some sort of external API like Google Maps. And all of these things tend to be duplicated inside of your main application or between applications. So let's pretend like we have a model that looks something like this. We're defining some attributes on one of our addresses called venue. We have to have all different kinds set there. We have to do our validations. We're doing formatting based on how we need to output this. Obviously, some of these would be decorators, but for the simplicity of the example. But the problem is that even with this simple of an example here, let's say that we had a user model as well. Well, the user model might have something called business address on it. And the functionality inside of there is going to be fairly simple or similar, because we're going to be doing similar things between both models. So when I find something like this that I think needs to be extracted, I first start off with a README. And what I tend to do is decide what I want the public API of the README to look like first, and then I build the gem out, the functionality of the gem out from there. So what I really want to do is I want to take this and I want to turn it into something like that. And I can move that thing into both the user model and the event model and dry up the code substantially. And how would I do formatting? Well, I would just call 2s on my address like anybody would expect inside of Ruby and pass it some options. and it would spit out the correct formatting based on whatever the options were that I passed in. Now, when you start seeing the benefit of this is, let's say I want to add additional functionality to this. Rather than having to go to each model independently, if I wanted to add internationalization, I could just add something to the gem where I pass in another option to 2S, and it's going to work throughout the application. The better part of this is that I don't have to test it inside of my application. I test it in the gem once, and then I assume that it's going to work throughout the rest of the application. What about if we wanted to add a formatter? We can just pass JSON, for example, create a new formatter, and again, only have to change it in one place, only have to test it in one place. Now, when I get done extracting my gems and I go back to my main application and I run my tests, everything still passes. But you notice there are slightly fewer tests now because we have the functionality extracted out of the gems. We don't have to test those in the main app anymore because we assume that the gem is doing its job, just like you don't test active record, you don't test active support because you know that it works and you know that it's been tested. Now we're going to talk about engine extraction. So when I extract an engine out, or I try and think of things that could be extracted out of my main application as an engine, I ask myself the same question in 3 different ways. What services does my application provide to its users? What would I pay someone else to do? And what services are others creating businesses around? So let's take an example. We've probably seen Harvest before. Harvest provides time tracking and invoicing. You could use their API as an integration point inside of your app, but you may have a client that doesn't want to use Harvest, or they have security concerns that Harvest doesn't meet, and sometimes, for whatever reason, they end up having to roll their own. You end up having to roll your own. And for the purposes of this example, we're going to go through a ticketing system, and this is going to be based on actual client work that we had. So I'm not just pulling this stuff out of the air. So this is a typical scenario for working with ticketing. When placing an order for tickets, we provide them with a shopping cart that they can use to store their purchase choices and give them a way to pay for them. Assuming that everything was successful, we send out an email for the receipt and the tickets to the user. Now, when I ask myself those 3 questions and I look at this scenario, I can pick out a few different things. Order processing, shopping cart, payment processing, notifications, emails, whatever. And that's in addition to the core business that I haven't highlighted yet, which is ticketing. So we're going to pull the ticketing module out of the rest of the application as an engine. And how are we going to do that? The first step is Rails plugin new with the name of the engine that you want to create, and then the option mountable. The mountable option tells it that you want a Rails engine and not a regular Rails plugin. If you all have never had to deal with Rails plugins before, thank your stars because they are awful. They were used before you could actually include gems inside of your Rails app, and they were So this is going to create a ticketing engine, and you're going to get some output that looks something like this. I know it's tough to see, but just bear with me here. So out of this list, you're going to see some things that look pretty familiar. These guys right here look very similar to what you would get whenever you run Rails new. So you see that there's an application controller, an application helper. You get some assets directories, a routes file, all that stuff. The other files that you see look very similar to what Claire showed you earlier whenever you create a gem. So you have your license file, your rake file, your README. You have a lib directory with the name of the gem inside of it, and then a lib directory with a directory with the name of the gem inside of that, and the version file. And then you also see a couple of files that you've never seen before. One is an engine.rb file, which is specific to whenever you create a Rails engine. And the other thing is the test dummy directory, which is used. It's kind of a hack to be able to test your Rails engine inside of the gem itself, like without actually having an external app, because there's literally a Rails app inside of your test dummy directory that you use to run your Rails engine against. All right, so once we have that, we're going to go ahead and push that up to GitHub, and then we're going to include that inside of our gem file. And we run, and all the tests that we have in our main app still pass, which is pretty reasonable. Now, after we get done with that, now it's time to start moving some stuff around. So we have a list of all of our models that are inside of our main application, and we're going to start to pick out the ones that are appropriate to the engine that we just created. So as an example, we have like an event that seems reasonable, discount code, ticket type, and ticket. So we're going to take those and we're going to move those over into our ticketing engine verbatim, like MV space path name, like that's all we're going to do. But when we do that, magically, all of our tests still pass. And the reason that all of our tests still pass inside of our main application is because when you include an engine and you look for a specific model, Rails is going to look in your main app for that, whatever that model or class happens to be. If it doesn't find it there, it's going to go through all of the engines that are included inside of your Rails application, and it's going to look at each of those in sequence. So because we included our Rails engine, we moved those files over. It's actually pulling those files out of the engine and not out of our main application. But the next step is a little bit more difficult. Now we're going to move our specs over. And this is where you're going to be getting the majority of your benefit from your creating your Rails engine and pulling stuff out. So we move all that stuff over. This is going to require a bit more work because let's say you're using Factory Girl. Well, you're going to have to install Factory Girl in your engine. Let's say you're reaching into places where you shouldn't reach inside of your main application. You're going to have to start thinking about compartmentalizing this ticketing engine into its own namespace and not trying not to reach across into the main application. So, but once you do that and you create your migrations and you get all that stuff taken care of and you run it, you're going to see that you get substantially fewer specs, right? Because those specs that you just moved are now in your ticketing application. But one of the problems that you'll run into, for sure, whenever you do this, is you'll have objects that are in your main application that you've moved over into your engine. And then as you create new engines, you realize that that model actually belongs in more than one place. This happens because typically we have at least one or two God objects inside of our Rails applications. It's usually the model that is defined by whatever your domain is. So in the domain of ticketing, it would probably be like event or ticket or something like that. And it's almost exclusively the user object. You start off with authentication, and then everything else that has anything relatively close to do with user, you just dump in the user object. And what happens is your user object will grow and grow and grow and grow until you can't handle it anymore and you can't add anything without it breaking other things. So we're going to look at splitting up our app into two separate pieces just for this example. We want to move our user object into ticketing because it makes sense that users need tickets. Users are going to buy our tickets, right? So we move all that stuff over into our ticketing application, and we start running our specs and making our specs pass. But we see specs that look kind of like this. And this doesn't really make a whole lot of sense in the context of a ticketing application. It seems more like something that would be reasonable to put having to do with like billing and accounts and things like that. But we just keep going, and we just get everything to pass. And we run our specs, and everything passes in our main app. And we run our specs in our ticketing engine, and everything passes, and we're good. But then we start on the invoicing engine. And it makes sense that we're going to put an invoice in the invoicing engine. It seems like a reasonable component. But who does the invoice belong to? Typically, it would be like some sort of account, maybe like a billing account. Well, we obviously have that functionality in here, right? We're not adding functionality, we're just moving stuff around. So where does that information live? Well, it happens to live on the user because users have billing addresses, right? It made sense whenever you did it the first time, initially, but now you realize that your user object actually has two different roles. It's an account, but it's also an event organizer. So what we're going to do now is we're going to take the everything that doesn't have to do with event organizer, and we're going to move it back over into the main application. And now the event organizer class gets just a little bit smaller, less that it has to do. When we run our tests, everything still passes. But now we're going to do the exact same thing and we're going to take the information that was in the user model that surrounded billing information, and we're going to move it over into the invoicing engine. Now when we look at what's left, on the user, this starts to make a little bit more sense. Because everything that's left has to do with one thing, authentication. So the user model that's left in the main application has only one role, and we teased out the other roles and split them up into the other engines. And once we do that, we still have an issue because we haven't changed any of the code that really works with any of those models very much, right? So inside of your controllers, inside of all of your mailers and things like that, everything is still reaching in to those engines and like touching all of those different constants. And we want to keep the coupling between the main application and the engines as low as possible. We want all of our engines to be like a black box that only has well-defined APIs for accessing it. So let's look through an example like that. So let's say we have a tickets controller and we have a create action on it. And you notice we're doing some relatively, this seems fairly reasonable. We're passing in params for an event ID and a ticket type that we want to buy, that the user wants to buy. We're looping over that a certain number of times, and for each time we do it, we're going to create a ticket, apply some discount codes, and send out some emails, just as an example, contrived example. What about, so the issue with this is that we have a lot of coupling going on. We're coupled to the event, we're coupled to the ticket type, to the ticket, to the discount code, and to some sort of mailer, something or other, right? And this is a problem because all of that stuff, or the majority of that stuff, is inside of the ticket engine, and we don't want to reach inside the ticket engine and grab that. So what about if we did something like this instead? We define an interface for our ticketing engine called box office. And that's going to be the only way that we access anything that's inside of the ticketing engine. We're going to call it register tickets, call a method called register tickets, pass it in all the information that it should need, and we're going to assume that it does its job. So inside of our ticketing engine, we're going to have all the tests for this thing, make sure that it does what it says it's going to do, but when we're inside of our main application, we don't have to worry that it's doing the right thing. We're just going to assume that everything works properly. And we're coupling ourselves only to the box office and to a method on the box office called register tickets. Now, ideally what you'd want to do is only have like one way of talking to a gym or an engine or whatnot, but that's not always reasonable or warranted. But you want to keep those coupling points as low as possible because when you go in and change it later, it's going to be much, much easier if that number is very, very low. In fact, let's say we wanted to send out emails, or let's send out notifications through iOS instead of email, and we wanted to do something like that, we could just go in and change that inside of the ticketing engine, and we don't have to change the main app to make that work. All right, so let's look at where we are. Say we've broken up our app into a few different engines and a few different gems. Now, this is real-world numbers. For an application that I talked about earlier, where we had a test suite that took an hour and a half to run, and we got everything down to about 2.5 minutes for all of those. That isn't exact numbers of engines and gems. And about 4 seconds, it was actually 4 to 10 seconds per gem per engine, which is substantially better. It was amazing. But the problem is that our acceptance test still takes about 20 minutes to run. That's a problem, obviously. So we went in and we looked at what acceptance tests were actually valuable, which ones weren't. We deleted the ones that weren't valuable, and then we set up a good CI run so that we could just push it up and not really have to worry about running the acceptance test every single time. We just let our unit test handle that. And this now allows us to have different developers working on different gems at any given time, and everybody's super happy because our team now rocks. And because everybody's using semantic versioning, you don't have to worry about a change that's made to one gem affecting functionality in another gem, because you're using that pessimistic versioning, and that works out really, really well. So then you make a lot of money. You lay out all your cash. Now, One thing that you have to think about, though, one of the benefits that you get out of this is, let's say you start making lots of money, and your Rails application, you max out the box that your Rails application is on, right? You can't add any more CPU, you can't add any more RAM, you're totally beefed up. And let's say also that you are potentially I/O bound. You can't fit anything else through the pipe. What do you do? So because we have split this thing out, we can go from something that looks like this. So we have our main app, and our engines are encapsulated inside this app, right? Because we're adding them to our gem file. But because an engine is essentially a Rails application, it's relatively easy for us to take one of those engines and pull it out into its own Rails application that sits on its own box. You run a couple migrations. It might even be hitting a separate database server. Relatively easy to do. But if you get really, really popular, you can actually scale those guys out, stick it behind a load balancer, and have your main app talk to the load balancer instead of talking directly to the application, and you can scale out a lot easier. So in conclusion, gems and engines can really, really help break up your application and make it easier to test and make you actually enjoy working with your Rails app all over again, and keep it from being an absolute nightmare. So that's it for me. That's me. That's my Twitter handle. Please follow me. Do you all have any questions?
What was the 80s reference?
It was War Games.
That's not obscure.
The picture was obscure. The reference was not obscure.
A technicality.
$20 for everybody.
Anybody have any questions?
So when you mentioned using the semantic versioning and pessimistic locking, do you mean you actually had multiple versions of some of the gems actively in use in the application?
Well, yes and no. It really just depends on the way that you have your development flow set up. So, I mean, if you have an application that's running in production, you can have other teams pushing up different versions of other gems without actually pushing them into production. But you can at least know that those, when you upgrade the main application, the versions of the main application that is or is not going to break. Anything else?
When you talk about splitting the concerns out the user model, can you talk a bit more about how you actually do that? Do you have two user classes, one in each engine?
Yeah. Yeah, so that is where you start getting into, it does take some work, right? Because you have to split up the user model into 3 different models. You'll have the user model that you originally had that has all the authentication information on it, but then you have to start creating new tables for those new concerns, and those become completely separate models, separate from your user model. And if you do, once you do this once or twice, you start realizing that what you really need to do is completely namespace all of your tables. So Rails will do this pretty much for you automatically if your model is inside of a module. So if you name a module, whatever your application name is, and you put a model inside of that, it'll look for a table name that is namespaced with your application name. So you can have a lot of these different things running in the same database. But then as you grow and you actually want to split those out and actually move that information to another application, you can move just those tables over to another database server, and it's relatively painless because you've already gone through the work of doing that.
I have a question. Mm-hmm. So you spoke a little bit about separating the engines out and having them running on different boxes, maybe load balancing between your main app or engines between engines, right? And I'm wondering how what's your communication mechanism between your main app and separate engines? Like, if you have it, it's one thing to have the engine mounted as an engine within your Rails app itself, because your box office interface in this thing, that's a model that lives either in your app or another one that talks and all the companies there, right? But when box office is a module that's living in app A, but it's talking to services in another engine, how does that communication, I mean, do you have to write something?
You essentially, like, what we had to do was we had to start off with some pub sub type of mechanism to get those things to talk properly and add, set up some queuing so that if there was a job that needed to happen, not all the boxes picked up that same job all at the same time. So it doesn't take all the pain away, but it does take a bulk, the bulk of the pain away for like actually extracting that application out. And if you do this kind of thing whenever you start with a Rails app and you start thinking about this stuff, maybe not breaking stuff out into engines, but think about things as the boundaries inside of your Rails app, then extracting them out into engines or gems becomes much, much easier. One strategy that we will often do is when we notice that we're going to be extracting a gem out, we'll add it to lib/whatever we want the gem name to be called inside of our Rails app. And then inside of Bundler, inside of our gem file, we'll create a gem and set that path inside of our Rails app so that Bundler is loading a gem literally from inside of our application. And then once we're ready, we'll pull that out and actually put that up as a separate gem somewhere else.
So what do you do when you realize, okay, we just extracted an engine out of this, and now we also realize we have some AJAX calls that are like, we have some dynamic JavaScript that's using this behavior that we just extracted into an engine.
We didn't have to deal with that too terribly much, but I guess I can't really speak to that because anything I say would really be just like pulling stuff out of the air. But we didn't have to deal with that very much at all. My guess would be that you would have to have one central way of talking to your application via like maybe some sort of just an API application that you would route all of your calls through, and then let that thing handle how all that stuff is supposed to happen.
Usually I just get reset and cry.
Always a valid option.
Anybody else? All right, cool, excellent. So we are going to be doing the BD Riley's thing afterwards. I think Owen Local is here and awesome. They're going to be sponsoring the drink up tonight.
Good job.
Good job, Jeff. Good job.
So yeah, my name is Justin. I'm with a company here called Own Local. We're on Capital Factory, which is a really great place to work out of. We take print and other traditional media advertisements and turn them into things that we can internet around and Google picks up and stuff. We're in the process right now of extracting big Rails applications into ecosystems of small applications and have all kinds of things from Rails 4.1 to like, we have a data mapper backed application running, which is truly terrible for our new people. But we have a ton of technology, have a lot of fun working, and just love to give back to the community. So we'll be buying you drinks tonight. So, woo!
So I think that's about it. We'll head on down to BD Rise, which if you go down Brazos, take a left on 6th, it'll be directly on the left there. So, look forward to seeing everybody out there. Thanks.